Hello everyone, this is Dave Noble. I'm a meteorologist with the National Weather Service here at the Missoula Forecast Office. The purpose for this presentation is to give you a deep dive into the impacts of the 2015-2016 strong El Nino in the Northern Rockies. I may go a little bit more into the meteorology, but some of you may dig this. There have been some recent research into what made this El Nino different from other strong El Ninos, and I'll briefly share some of that. But first of all, here's a monthly overview of the precipitation percent of average. The green means above average. The dark green means well above average. And wow, look at that precip in November and especially December. This graphic shows the average position of ridges, green to yellow colors, and troughs, blue colors, each month of the 2015 to 2016 season. Right off the bat, my eyes gravitate toward the elongated upper ridging over the northern Pacific. That's shown in November, showed it also in December. This, combined with the cold air pouring out of Siberia and a plethora of tropical thunderstorms in the western Pacific, not shown, allowed for the jet to be strong and also cause a very long subtropical moisture fetch. Very La Nina-like. We had multiple atmospheric river events that started in October and lasted through midwinter. So when you combine the moisture plumes with colder air, that equates to a lot of cold smoke or powder here in the Northern Rockies. Like what occurred especially in December. One common denominator that you see in the months of January through March is the deep upper level low in the northeastern Pacific. This pattern allows for warmer air to ride southwest winds up into our area, allowing for much milder weather. So you might be wondering, why did November and December act more like La Nina than El Nino? Recent research found that the 2015-2016 had record warm waters towards the dateline or central Pacific. The left image shows the sea surface water temperature average for the December through February period. The black box is considered the Niño 3.4 region. The right image shows the departure from that 1991 to 2020 average, with green to yellow to red colors signifying warmer and blue colors cooler. A 2017 NASA study that compared the strong El Nino to the other strong El Ninos of 97-98 and 1982-83, they discovered that this El Nino of 2015-2016 was the strongest in terms of warmest temperature anomaly in the central Pacific compared to the other two. This shifted the anomalous tropical convection further west and had downstream effects, including enhanced jet stream and northeastern Pacific troughing. Researchers at the Scripps Institute of Oceanography were puzzled that Southern California didn't get all the rain that was promised. So they looked into what possibly made the 2015-2016 different, a study from 2017, and they found that the key features that were different compared to previous El Ninos were sea surface temperature and rainfall in the Indian Ocean and Western Pacific. The atmospheric response to these anomalies meant that storms that might otherwise have made landfall in California were pushed further north, bringing record precipitation to the Pacific Northwest instead. Also to note, during that season, the Indian Ocean Dipole, which is a kind of looking at the water temperatures from Africa to the eastern Indian Ocean, that was in the positive phase. The PDO was in a positive phase with warmer waters along the northeastern Pacific, and then the AMO was positive, warmer waters in the western Atlantic. All right, let's get into the Northern Rockies impacts. November 2015 was generally average to below average for temperatures, but near to above average precipitation. Right off the bat, we had a closed low tracked across southwest Montana and brought close to a foot of heavy snow to the mountains. A short wave moving out of northwest flow brought snow to west central and southwest Montana. 5 inches fell in both Anaconda and Butte. In the table, the blue numbers signify below average temperatures, while black is around average. Green means above average precipitation, and brown means below average. Salmon, by the way, ended up being above average for snowfall that month. By November 10th, moderate snow fell in the Butte area. Then a strong jet brought high wind and blizzard conditions in the backcountry by the 17th and 18th. Gusts to 61, Grangeville, 70 miles an hour occurred in Clearwater County and many locations in western Montana, and there were power outages, trees down, roof siding, car damage. And then we had an Arctic system that occurred during the Thanksgiving week and brought flash freezing of roadways, snow, and blowing snow. That shows you the atmospheric river that brought copious amounts of water into the mountains November 13th through the 14th. The satellite image shows the plethora of clouds associated with the river of moisture over the northeastern Pacific. The right image shows the long stretch of water vapor associated with the atmospheric river. And the table kind of shows some of the top precip in our area, with Hawkins Lake Snowtell receiving 3.6 inches of precipitation. Here's a look at the upper level pattern on the left side during the Arctic. An upper level low in the kind of purple blues closed off and moved south into Oregon and California and helped to draw the Arctic air south and westwards across the region. The right graphic shows the colder temperatures in the low levels. The white color is near freezing, and then the blues are colder than that, and sea level pressure is notated by black isobars. This Arctic set the stage for ice storm events in early December. So in December of 2015, it was non-stop action for much of that month. We had freezing rain with icy roads across much of northwest Montana on the 4th. An atmospheric river brought higher snow levels and freezing rain that caused the icy roads. There were road and school closures in many locations. On the 9th, heavy snow fell in the mountains along with high winds up to 80 miles an hour. Some of that wind made it down to the surface with Chinooks in Deer Lodge and in the central Bitterroot Valley. 1 to 3 inches of precipitation fell in the northwest Montana mountains, and they had their first natural avalanche cycle of the season. Just as a side note, the west central avalanche folks wrote in their synopsis of that winter and said it was pretty stable for much of the winter, and even probably the most stable avalanche forecaster saw in 30 years, which is kind of interesting. So difference in the west central Montana versus like northwest Montana. Here's a look at what the atmospheric river looked like for the December 8 to 9 event, and also for the heavy mountain snow event on December 12th through the 14th. These show kind of like that plume of moisture originating from Hawaii, kind of in that bottom left part of the images, and then extending all the way north and east towards the Pacific Northwest. Here's a look at the daily observations at the Noisy Basin Snowtell in the month of December. You can see almost every day there was precipitation. By Christmas time, we were under a cold trough and there was plenty of dry snow that fell. We had 4 heavy snow events mid to late December. 18 inches of snow fell at Lost Trail in the 12th to the 14th, and almost 4 inches in Grangeville. 12 to 16 inches of snow fell from Huron to Kalispell and West Glacier just before Christmas. Overall, the temperatures were milder in western Montana except for Butte, which was cooler than average. Pierce, Idaho picked up a whopping 43 inches of snow that month, which is almost a foot higher than the December average. And they were milder than average. Salmon in Idaho was near average, though their highs were cooler. Okay, by early January there was a pattern change. The first 10 days. High pressure set up as Pacific troughs impacted more of the southwestern U.S. with a more active subtropical jet. Then we had a milder Pacific wave that brought freezing rain to Mineral County on the 13th. Also, convective snow showers brought heavy snow to Big Fork. The northern Swan Range picked up almost 4 feet of snow in 3 days. The northern Swan Range picked up almost 4 feet of snow in 3 days. There were also natural and human-triggered avalanches in northwest Montana. Butte came in 2 degrees colder that month, but the other stations were milder than average. On January 16th, there was a high wind event that brought blowing and drifting snow to US 95 south of Grangeville, Idaho. The winds were strong enough to push a charter bus off the road, and a semi got jackknifed. You can see that in the distance of that picture. Here's what the atmospheric river looked like. Left side, that's from the reanalysis, kind of showing that big plume. And then the satellite showing all the clouds and the moisture aimed at the Pacific Northwest. This plume of moisture brought 1.3 inches of precip to Flat Top Mountain in Glacier National Park. Another atmospheric river brought more precipitation to the mountains, and snow also fell in the valleys later January. The satellite shows that long fetch of moisture over the northeastern Pacific. And you can see in that Crater Meadows Snowtell in Idaho received 3.3 inches in just a few days of precipitation. So by the end of January, the left side here, the graphic shows the snow water equivalent in terms of percent of the median. Northwest Montana was below 100%, 80 to 90%. The Clearwaters to the upper Clark Fork showed like 94% of the median. And then towards Lemhi County, Salmon Basin, 119% of the median. And then the right side shows you the snow depth on January 30th. February 2016 ended up very warm and drier than average. The Kalispell average departure for high temperature ended up being 7.8 degrees above average, which was incredible. The average high for the month in Orofino was around 51 degrees, almost 5 degrees above average. It even got close to 60 degrees 2 times in Orofino. There was a heavy snow band that brought severe driving conditions to Lookout Pass to St. Regis on I-90 on the 2nd. Then high winds to 70 miles an hour along the divide on the 15th, and a debris flow occurred on Highway 14 between Grangeville and Elk City. And here's a photo of that slide. Pretty impressive. Photo is courtesy of Idaho Transportation Department. March 2016 also ended up being very warm with near to average precipitation. There was a high wind event that impacted the Bitterroot Valley, Deer Lodge, and Lemhi County in the first 2 days of the month. Then snow bands brought snow to portions of west central Montana on the 17th. In the mountains, mild days and cool nights occurred with occasional precipitation. Pierce, Idaho saw a high of 67 on the 21st. I don't have a slide for April, but that also ended up being warm. In fact, the snowpack in the mountains started to melt by mid to late April of 2016. Alright, so here are the last few slides just showing some of the significant temps and snowfall for the whole season. The coldest low temperature recorded in our region that 2015-2016 season was 21 below at Polbridge, which isn't really that cold, on January 4th. 19 below at both May, Idaho and Butte. Kalispell saw its coldest temp of 12 below January 2nd. Missoula 6 below on the 3rd of January, and Orofino saw its coldest of 18 degrees on January 4th. And lastly, Salmon, Idaho had 12 below on January 3rd. Here are the warmest high temperatures during the months of December through February. Slate Creek had 71 on the February 26th. Grangeville, Idaho saw 63 on February 11th. 54 degrees in Kalispell on the 26th of February, and Missoula saw 56 degrees on December 9th. 51 in Butte, February 26th. And 50 degrees in Salmon on February 20th. Here's a look at the total snowfall that fell across northwest Montana. Just a bit of caution, as some of these stations may not have reported every snowfall event, and some of these numbers may be a little erroneous, so just take them with a grain of salt. The winners were Haugen with 9.6 feet, or 115.6 inches. 90 inches of snow at Lindbergh Lake, which is north of Seeley Lake. But you know that 90 was still 46 inches below average. Look at that, 72.5 inches east of Big Fork. That was pretty impressive. And the official National Weather Service reporting station at the Glacier Park International Airport received 41 inches, which is 13 inches below average. Here's a look at the total snowfall that fell across north central Idaho, Lemhi County, and southwest Montana. The winners were Dixie with 162 inches, or 10.5 feet, 86.9 inches at Yellow Pine, and 77 inches at Headquarters, Idaho, which was still 3.5 feet below average. We didn't have an observation site for the 2015, 2016 in the Butte area, but the airport picked up close to 3 inches of water between November and March, which is around 2/10 above average. Well, I hope you enjoyed this deep dive into the most recent strong El Nino. Have a great day.